Hi, I'm Sven. One more thing about scaling up using the cloud. We've heard it. A task uses up all the computing power? Use a stronger computer. Parallelize it to get done faster. And where is more scalable computing power available than in the cloud? Hence, problem solved. Except no. So today, let's have a look at the scalability of our decision problems. Welcome to Optano. A long time ago, computation power came in small blocks of electronics, and every one of us owned a set of tools to open and tune our home computer. Today, computation power is available by firing up some cloud machines from one instance to a vast farm in a matter of seconds. When we want to run computationally expensive tasks, like, let's say, crunching optimization problems, this is at our fingertips exactly when we need it. So everything is fine then? Actually, yes. For a lot of problems, it's really as easy as that. But to achieve that, we should keep a couple of things in mind right from the beginning. And honestly, I would like to know whether scaling up in the cloud works before I sink my budget by blocking half the internet's capacity for a task that's not worth it. From an optimization point of view, there are three topics I need to think about to get an impression on whether the cloud will make everything so much faster. The first and most obvious is memory consumption. Typically, we need to hold the complete optimization model in memory, including all the variables and constraints. When we want to speed up everything in the cloud, we need to copy the whole model several times, both for the solving process and for the scaling process. So we need to get a feel on the size of the dataset and the size of the resulting model. We must try to keep the memory footprint low if we want to go to the cloud. This goes hand in hand with the second topic, parallelization. Scaling up typically means something like running in parallel really often. This could mean regular multithreading, but also distributing the problem onto several machines entirely. But will our problem parallelize well? Sometimes we don't need to think about this, because some solver will take care of it. But if we target cloud-based scaling, we are better off to design our problem right from the beginning, such that it can be broken down into independent subproblems that can be solved individually. Now, this leads to the third topic, complexity and structure. Of course, different types of problems have different levels of complexity, but a very important question for all of them is this one. Is there anything that needs to be evaluated globally? Like, for example, overall traveling costs for some sports league schedule? Because this could be a blocker for parallelization. There are three main factors that impact the applicability of scaling optimization problems: memory consumption, parallelization in general, and structure specifically, the last one being the trickiest. To reap in speed-ups by scaling in the cloud, we need to tackle these problems right from the beginning. Then we are on the right track to really impressive runtime improvements using cloud services. See you next time and stay safe.